From 7.5 and 7.6 LTQs, learning targets, solve each equation, round to the nearest hundredth, always read the prompt, and let's get started. Okay, so we're going to solve these in lots of different ways depending on kind of how the problem is. So this one, the first thing I'm going to notice is that 2 and 32 are compatible because 2 to the 5th is 32. I mean, if there's one thing you learn this year besides foiling, is that 2 to the 5th is 32. That comes up all the time. So if 2 is 5x minus 1, and I can rewrite 32 as 2 to the 5th, then I have base equal to base, which is awesome. So I can set exponent equal to exponent. Okay, so add 1 to both sides, plus 1, and divide by 5. So this answer is x is 6/5. So if you were to, put this in your calculator, obviously, to check, you would do 2 to the parentheses 5 times 6 over 5 minus 1 in parentheses, and you'd get 32. Okay. All right. So x equals 6 over 5. Okay, here, bases are compatible. We like that. 2 to the 3x. 4 I can think of as 2 squared to the x plus 1. So cancel. So I set 3x equal to, and this is a power to power. So this is 2x plus 1. 3x equals 2x plus 2 minus 2x, x equals 2. Quick check. 2 to the 3 times 2, is that equal to 4 cubed? Well, 2 to the 6 is 64, and 4 cubed is 64. Checked, and we're good. X equals 2. Okay, phone's ringing. Let me pause. All right, next page. 2 to the x equals 3. Okay, so now I can't write 3 as a power of 2. I mean, I just can't. So this is where the logs come in. And so I'm going to take the log of both sides. Okay, so what did I do right there? I just wrote log on both sides of this equation. And what that property does, the power property of the logs, is going to pull this x in front. That's the magic of a logarithm. X log 2 and equals log 3. Okay, so logs are not, everybody's all scared of logs. Logs aren't that scary. Log of 2 is just a number, and log of 3 is just a number. Okay, they're just numbers. They're just logarithms, okay? So you can treat them as numbers. Don't go to decimals because that gets too messy, but just know this is just a number. So if I have log 2, log 3, I can divide this side by log 2. It's just a number. This side by log 2. That's totally normal and doable. And this is just x equals log of 3 over log of 2. Okay, and as a decimal, that's this number. And watch what happens if I raise 2 to that number. I get 3. And that's what the logarithm is doing for us. Super cool. All right. This one, to solve this, I'm going to go to exponential form. So different plans. Here I was writing in the same base. I could write these in the same base. Here I'm using a log on both sides to pull down. Now I'm going to circle around the problem. And this is why people struggle with the logarithm chapter 7, is because it's not like 20 problems of the same thing. You're constantly doing something different depending on the problem. And as students, you want to do the same thing every time. But we're getting older and more advanced, and every day is not the same, every work day is not the same. So you got to get used to every different problem being a little different technique, and that's what this is training you guys to do in terms of application to just life in general. All right, so this is 1 over 10, and that equals 2x. Multiply both sides by 10. This is 1 equals 20x. Divide by 20. X is 1 over 20. All right. If you were to put that into the calculator, that's a common log, so I can do that. Log of 2 times 1 over 20 certainly equal to negative 1. Okay. Number 4 is, okay, this one. So this one, different strategy. Now I'm going to condense over here. Condense. And then I'm going to circle around the equation just like I did this one. So this is like 4, except I had to condense first. So log base 10 to the 8th is equal to x over 3. All right, so this is log base 10. So 10 to the 8th power is equal to x over 3. Let's just cross multiply that up. 3 times 10 to the 8th is equal to x. Okay, well, 10 to the 8th is going to be 1, 2, 3, 4, 5, 6, 7, 8. So that'll be 3. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we can watch that in action. 3 times 10 to the 8th. And you get that 1, 2, 3, 4, 5, 6, 7, 8. All right. $300 million. Okay, next one, natural logs. So natural logs are going to involve the E. Natural logs, you're going to use ln. Okay, it stands for logarithm natural, and so we're just going to use that. So you're going to isolate here, divide both sides by 5, and take the ln of both sides. Pull that x down with ln. All right? And the good news is that's a property, that's log base e of e, so that goes to 1, and this is x equals ln of 5. Natural logs are super easy. So if you had to give it as a decimal, 1.609. All right. Same thing here. Well, actually, no, this is just straight computation. This is just e to the 2.5. That's it. Okay. That's just straight computation. X equals, plug that into the calculator. Done. So your e is right above this ln. All right, same thing here, straight TI, just straight TI. ln of 0.763. Okay, that's it. Okay, we just plug that in the calculator. 0.270. Okay, so this one, circle around. Base here is e. E squared is equal to all of this. E squared is just a number. Oops. It's just a number, so it's going to behave algebraically as just a number. All right, so I'm going to take e squared. It's just a number. I'm going to leave it alone. Minus 2 minus 2. Minus 2 minus 2. And then divide by 3. So e squared minus 2 over 3 equals x. And if we were going to do that, there's e squared minus 2 from it, divided by 3. All right. So if you were to check it, you'd go ln of 3 times 1.796 plus 2 we should get very close to 2, which we did. Sorry, I keep putting that down where you can't see it. ln of 3 times 1.76 plus 2, just going into this original. And equals pretty darn close to 2, which is good for us. Okay, last one. All right, so this one I'm going to condense. Get all of that behind the logarithm, so that's adding. So it's going to be 3 times x plus 3 equals 2. So the ln of 3x plus 9 is equal to 2. So now it's just like the problem before it once you condense. And that property, when you're adding log, you can take what's behind the log, that's called the argument, and you can multiply them. So now I'm going to circle around the problem. That's base e. E squared equals 3x plus 9, just a number. E squared minus 9 equals 3x, because I have minus 9. Divide by 3, divide by 3. So x is equal to e squared minus 9 over 3. Sorry, I made a mess of this one. E squared minus 9, there we go, divided by 3. X is equal to negative 0.537. All right, and so ln of 3 plus ln of, what did we say our answer was? Negative 0.537 plus 3 equals 2. Okay, so you can just check them on your calculator, leave the problem, and say, smaller, I got that 100% right. All right, last one, write each expression as a single logarithm, so condensing. So this is ln of the coefficients go up, 3 squared. So ln of 9 times ln of 5. Well, sorry, I got ahead of myself. When you add, you write one logarithm, and if they're adding, you multiply them. So this is just ln of 45. Okay, looks like I got off my blanks, didn't I? So this is 5. Well, I'll fix that. I'll fix that when I have to post the key. That's 5. So we'll just do 5, 6. Not a lot of room there for all that I was writing. So 6 is ln of 45. All right, and if you were to do 2 ln 3 plus ln of 5, okay, and then you would do ln of 45, do the same thing. So if you do the problem as it is, 2 ln of 3 plus ln of 5, and then ln of 45, same thing. They're just two different looks to the problem. And then number 7, up you go, ln of a to the 4th, up you go, minus ln of 3b, and that means to divide them. ln and then a to the 4th over 3b. Okay, that's just rearranging stuff, not really getting to any numeric value there. All right, so that's the end of the LTs, the learning targets, or the little mini quizzes that we just kind of go through as warm-ups for Chapter 7. All right, see you guys.